Promises, promises, promises. Empty promises. Broken promises. Fulfilled promises. JavaScript promises. JavaScript Promises, a modern feature that in many ways has revolutionized the way we write asynchronous code or code in general. This is episode 12 of a 10-part series called 10 Things JavaScript Developers Should Know, but probably don't. This is the last video ever that you will have to watch on promises. I promise you. Okay, no, hold on, stop. No more promise jokes, okay? This is it. I'm not gonna do it anymore. I already did it in episode 11. That's it, no more. I promise. In the last episode, I showed you the difference between synchronous and asynchronous code. We also touched on callback functions as our first attempt to write asynchronous code. We also touched on callback hell, so if you haven't watched that, go watch it somewhere up here. In this episode, I'm going to show you how promises can help us write better asynchronous code. We'll take an async example and convert it into promises. I'll show you how to create promises and how to use promises, two very different things. And along the way, hopefully you'll see why you should be using promises to begin with, using my beloved the why method. We'll also talk about the different phases of a promise, how to handle errors, and finally how to chain multiple promises together. So buckle up, kids. This is gonna be an information-heavy episode. As a quick reminder, synchronous code blocks the execution of any line that comes after it. Asynchronous code does not. If I have two functions here that take 5 seconds to complete, one is synchronous and the other one is asynchronous, when I console log hello after each of them, I won't see the log after the synchronous code for 5 seconds, whereas I'll see the log immediately after the asynchronous function. That's a slight oversimplification, but that's basically the difference. Now, obviously, we don't want to be blocked, right? Slow equals bad. We want our code to run smooth and fast. Let me show you some real code because it's important to understand the difference before we move forward. Now, I already wrote two functions here that you can't see, and it doesn't matter what's inside them. One is called syncfunc, short for synchronous function, and another one that's called async func. Async func you up. Async func you up. You know, a little bit of Bruno Mars? Yeah? No? Just me? Okay. To the browser. All right, so I'm gonna call this sync func first and do a console log right after. Let's see how long it takes. It's a little bit slow. You see the console log itself is getting blocked, and we're not seeing the log here anywhere. There we go. And it took, what, 3,500 milliseconds, and the hello showed up. Whereas if I call the async function, you can see immediately after 0 milliseconds, my hello appeared, right? So the async function doesn't block anything. It just goes off on its own. The app moves on, and no matter how long the function takes to finish its job, it never affects the timing of our log. Async func you up. Async func you up. So if async is so awesome and it's non-blocking and it's so great and we should always be using it, that potentially creates a small little problem for us. Now, what happens if I need to follow the async process and do something after the async is done? Because with the sync function, right, with synchronous code, I know when the function finished running. Because it blocked everything else. Whereas with async, I may not know exactly when that function finished doing its thing. Well, can you give me an example? Sure I can. Craig. A good example is if I need to make a call to a backend API in order to fetch some data, like today's weather, for example. If I want to show that on the screen, I have to, 1, call the API, 2, wait for the data to come back, 3, when the data comes back, I receive the data, and 4, display the data on the screen. I need to wait for the data to come back, but I don't know how long it's gonna take. It depends on my Wi-Fi connection, my device, the servers. There's just so many other things that are in play here. It's an unpredictable amount of time of wait. In those cases, I can't do this because weather will be, well, undefined. Why? Because getWeather is asynchronous. So the log is gonna run before the value of weather is set. Actually, that's not true. The value of weather is set to undefined because the getWeather function does return something, but it returns undefined. But that was the rule we saw before, right? The code doesn't wait for any asynchronous operations. And that's the advantage of async code, right? That it's non-blocking. So if getWeather was synchronous, right? Return a value like a string like this, it would work, right? I would get the sunny value back and assigned to my weather variable. But I have to make a round trip to the backend and ask the weather API. Now this code returns undefined. I'm gonna represent the backend call with a set timeout throughout this whole video instead, just to make things a little simpler for now. But I will come back towards the end of the video and replace it with a real backend call using the fetch API. So the issue is our function no longer returns a string. It actually returns undefined, like I said. But the real issue here is that the value of weather needs to be set before I can do anything meaningful with it, whether it's logging it or doing something more interesting like displaying it on the screen. Now, one way to fix this would be to set the value of weather inside the getWeather function. However, this is pretty terrible. Why? Because to do anything meaningful with the weather data, I have to do it inside the getWeather function. So if I need to add it to the screen, I have to go inside that function and do it there. That's awful because getWeather now does more than just getting the weather. It changes the value of weather, which is a side effect, if you know what that means. Not good, but even worse, it does DOM manipulation. And that's just way too much for one function, because that means to use that function, I have to use all of it or none of it at all. Now, one way to improve this would be to maybe set the value of weather inside another function called, I don't know, weather received. Okay, a little better, no more side effect, but still not great. Because now getWeather only works with the weather received, aka they are tightly coupled, meaning I still can't use one without the other. If I call getWeather, it will eventually call weather received. So I can't reuse them for any purposes. A slightly better version of that would be to decouple them and send the weather received function into getWeather as a callback function. We talked about this in the last episode. So this way, getWeather doesn't know anything about weather received, and it doesn't even care, right? It doesn't care what happens after that. It just knows that there is a function coming in as a parameter, and I'll call it when I'm done with my thing. Now we've decoupled the fetching logic from the DOM manipulation logic, which is great. It makes our code a lot more reusable. I can pass different functions to getWeather as a callback, and vice versa. I can have different functions with different values call weather received, and so both of our functions just became a lot more useful and reusable. So here's an example of a different callback, for example, right? Say if I want to display an icon based on the weather forecast, right? In this case, I can pass a different callback into getWeather and it still works. So great. This is a callback solution that we already talked about, and which is fine. So now we want to take this example and make it better using promises. If you think about what a promise is in real life, when someone makes a promise to you, there are always two people involved: the person who makes the promise and the person who the promise was made to. The same thing happens when working with promises in code. There are always two pieces involved: the maker and the receiver. The maker is a function that creates a promise object and returns it. The receiver is the part of your code, could be a function or not, that calls the maker and receives the promise and does something with it. These are names I just made up, so you can call them whatever you want, but the point is that there are two parts to any promise: one that makes it, one that receives and uses it. The maker is an asynchronous function, so let's focus on that first. So here's the same getWeather function as before. Instead of a regular value like a string or something, it creates a promise object and returns it. So new promise. And the idea here is, because the async process takes an unknown amount of time, the function needs to return something immediately. All functions need to return something, because otherwise it will just return undefined. So instead of returning the actual data, since we don't have it yet, it returns the promise of some data. It says, hey, I know you want the weather data. I don't have it right now. I need to go get it, but in the meantime, here is a promise object that I will fulfill as soon as I have the actual data. That way you know the data is coming soon. It's like a train ticket in real life, right? When you buy a train ticket, you don't get the train ride right away, but you get a promise of a ride in form of a ticket. But that ticket will eventually turn into a train ride. So that's what a promise object is. It's an immediate object that you can receive right away that indicates that there's more to come. The promise object takes a function where you can add actual async logic. So this is really the meat of your code, right? This could be your backend call, could be your pizza making from last episode, or waiting for the train, or however you want to think about it. The real bulk of the async logic goes inside this function. Also, this function itself takes two parameters. One that you can call if the promise is successfully fulfilled. Say the weather data came back from the API and it's called resolved, so you can call that. And the other, if the promise fails, say you couldn't reach the API or your Wi-Fi went down, or for whatever reason you couldn't fulfill your promise, that's the one that you call, and it's called reject. We'll cover those in a second, but let's take a minute and talk about the different phases of a promise. When you first create and return a promise object, by default, it's in a pending state. It means we're waiting. When you call resolve or reject, it's no longer pending. It gets, well, resolved or rejected. So these are the three states that a promise can have. Pending, which means we're waiting, fulfilled or resolved, which means it was successful, and rejected, which means it's done, but it couldn't accomplish what we expected it to. The last two can also be referred to as settled sometimes, but basically, you get what I mean. So don't worry, we'll see examples of each in a minute. So this was a little bit about the promise maker. Let's put the maker on the side for a second and talk about the promise receiver. Hold on, coffee sip. So the receiver. So that would be wherever we call our async function from. The difference here with a callback is we normally pass the callback into our function, right? But with promises, we don't do that. Instead, we get the promise object back, right? That's what the promise maker returns. So let's assign it to a variable and see what we can do with it and how to use it. To the browser. All right, so let me clean up all of this and let's do function get weather, right? And I will return a new promise. Promises. And we said it takes a function itself that has two parameters, resolve and reject. And what I'm going to do is I am going to create const promise equals get weather. When we call that, let's log and see what the promise object does. Boom, it's pending. Nice, we talked about that, right? It's the waiting part of the async process. When you first create a promise, like I said, by default, it's in pending. And the reason why it never resolves is because we haven't called resolve or rejected yet. So it gets stuck in the pending state. And that's like our train ticket. We haven't used it yet. The train hasn't showed up yet, but you do have the ticket, which is right here, this promise object. So this guy has a bunch of methods on it. So if I do dot, I don't know if you can see this, but we have catch, finally, then. The one we're interested in right now is then, which is called when the promise resolves successfully. So we can add this to our, it takes a function, we can add this to our object and say, boom, function data. So it receives some data, and I'll show you what I mean in a second. And let's console.log our data. So now let's go back to our promise creator and let's call resolve and send in Sunny. And boom, look at that. My console log now receives Sunny. It's exactly what I passed into the resolve function, and it works like magic. So interesting. So it seems like the resolve right here is just a reference to the function passed into then. And it is, if you're thinking that. Nice job. Actually, a then block, like this code right here, can take two different parameters. One is this function. So I'm gonna reshuffle these things. So I can actually have another function as the second parameter, which will take another data. And let's do that, console log. You know what? I'm gonna make this super obvious for us. First param, I wanna show you exactly what's going on so you don't get confused with the data. And this is also data, so I say second param. Right? So what is so important? Why is it necessary? What is the second parameter necessary? What is that one? Well, that gets called if I, instead of resolving, do a reject. Second parameter gets called. So now you might think, wait a minute, this is already a lot uglier than callbacks and a lot more code, and it's a lot longer. So why do we like this again? Good question, Oli. Well, for one thing, this isn't exactly how we write them. So to start with, we don't actually need this promise variable here. I can just go directly call the function and do my .then. So the same result happens here, right? And also what I can do is I can take these functions and give them their own named functions. I can say function on success. Let's do that. And data. And I can create another one for on error. And so inside my then, I can say on success and on error. Let's get rid of all this. I don't need that. Let's just clean up a little bit. Then for this would be error. Let's rename these error and error. And success maybe takes the data, and I can say success. And error can say, hey, I received an error. And over here, I can change this error. Boom. So if I decide to reject it, if I choose to call the reject, it actually goes straight into the on error. And if I call resolve, it will go into my success. This is a lot nicer, right? And what makes it even nicer is that we can now start chaining promises to each other. If I have a sequential number of things that need to happen one after another, I can write it this way. So let's say I get the weather, and based on the weather, I need to get like an icon, get weather icon. And let's say this function takes a value of weather. And actually I need to, you know what? I'm gonna do this set timeout because right now it's not asynchronous and I want to make it absolutely clear what's going on here. So let me add this after 100 milliseconds so we don't have to wait too long. Success sunny, that's great. So get weather icon. So what I mean by chaining is that I can call get weather, and then I can call get weather icon. And let's say get weather icon does the same thing. It returns a promise, but instead of doing the exact same thing, I'm gonna write a switch statement here that says whatever this weather that comes through is, based on that, switch case, if the case is sunny, I'm going to return, because if you don't know, now you know. I'm going to resolve. Let me bring up my emoji picker. What do we want? We want sun. Let's do this sun with the face. Kind of creepy, but that's fine. I can resolve that, and then I can, oh, it's a string. Ugh. And then break. If it's cloudy, and you'll see, I'm gonna actually eventually use the real data, use my actual data from today, from right this moment, and we'll see it's gonna be really cool. And if it's rainy, I'm going to pass rain to my resolve. Don't judge my emojis, okay? What I've used in the past. Let's give it a default, which I'm going to, let's say reject. Oh yeah, that would be cool. Reject, no icon found. Let's do that. And after a second. All right, so what's going on here? Let me bring these guys up a little bit. Cool, so I call get weather. Get weather does what it needs to do, and it resolves to sunny. It says today is a sunny day. Then we called get weather. Wait a minute, we didn't call it and pass in the actual information. Don't I have to do this like some kind of the parameter? How does it receive the weather? How does it receive that? Right. Well, that's the beauty of the chaining of these these promises, which is whatever gets resolved, right, in the first one, that data goes into the next function if they're chained as a parameter. How awesome is that, right? So at that point, then we say, all right, on success, everything was successful, and that's the result of the entirety of the sequence. Or if it failed for some reason, so let's say I change this to be cloudy. Nope, cloudy. Nice. What about rainy? Buyakasha. Now, I didn't cover a lot of the cases. Like, what if it's partly cloudy? Partly cloudy. Error, no icon found. So that called the on error. Now, another interesting thing about all this is this chaining doesn't have to stop with two functions. You can chain as many functions as you want, and you can see the information will flow from one to the next. Now, it may not seem obvious, but there are major readability benefits to what we have here, and a lot of problems with callbacks that we just don't have with the promises, especially when you have multiple and hopefully lots of different steps. I touched on this on episode 11 about callback hell and the pyramid of doom. I looked it up. It's not called sideways pyramid. So comparing these two, I'm gonna show you in my trusty animation board, comparing the callback hell to the simplicity of the promise syntax. When you compare those two, it gets more and more obvious the more callbacks you have. Say I have a super long sequence of events that need to happen back to back, which is not uncommon, by the way. It's a very common thing that we have to do quite often in modern code. It'll end up something like that. The pyramid of doom, right? And you can probably tell why I called it the sideways pyramid. I mean, that makes sense. It's like a pyramid on its side. Whereas with the promise syntax, it stays no more complex than this. I mean, the benefits should be really obvious to you. You can swap out one layer for another in the promise implementation, whereas with the callback hell, it's a lot more involved. So if you implement the promise solution, modifying that code is going to be a lot easier. Another benefit of the promise is that there's no callback, so we talked about that. But there's no callback that's passed into the functions. So the only thing that passed into the functions is the actual parameters they need to perform their operation. Nothing about handling success or error. So that makes our function signatures smaller and shorter. And another thing I love about promises, which is related to function signatures as well, is what happens if one of my async functions fails. In the callback scenario, normally what we do is you would have to send yet another parameter into the function and you call it based on whether or not you have an error. With promises, you don't need to do any of that. Remember the reject parameter that every promise gets? Well, that's exactly what that's there for. If for some reason your async function fails, you can just call the reject function, and on the receiver side, you can handle it. And that's where it gets a little bit tricky because you can handle it in two different ways. You can either pass a second parameter into the then block. I showed you that. Actually, we have it here on error, right? You can either do that, or you can have an entirely dedicated block that's called catch. And you can, instead of doing that, you can pass the on error to your catch block, which is basically, a catch block is basically like a then block that only takes one parameter instead of two, and that one parameter gets called when on the creator side, reject is called, reject. Okay, so I wanna actually do this again and simplify it a little bit. So let's say I have a function called fun1, one ton, return a new promise. By the way, some of you might think that I repeat myself quite a bit when I make these videos and I type things from scratch, and that might take some time. I recommend you, this is by design. I do this because repeating these steps is where you end up learning the most. If you just copy code from me or from Stack Overflow or even from yourself, eventually you're just not going to be exposed as much as you would be if you went ahead and wrote the code yourself. So this time I'm gonna do a little arrow function. Hopefully that won't cause any issues for me. And I'll take the resolve and the reject. I'm gonna do this set timeout, set timeout. By the way, how do you like this new code editor thing I got going on? This is the first time I'm doing this, and I actually like it because I don't have to log as much. So if I went ahead and rejected something, and I said error, or let's say 404, it's some kind of error code, right? So if I do that, and let's say I have another function here, I can copy pasta, not a big problem. And this was function 2, and instead of rejecting 404, it resolved, right? Let's give it mustache man. No, let's do it this one, fake mustache. Okay, and as before, I have unsuccess. The data that comes in, I'm gonna do a console log data, and I'll do on fail, on error, and this would come in as some kind of error code, right? Let's play around with some names. Let's see what makes the most sense. And here I'm gonna say error and spit out the error code. So now here's what where we can play around with the differences between catching the error scenario inside a then versus inside a catch. So I'm gonna call fun1, which is our function that returns a promise, okay? And then I can say, once that's done, call fun2, okay? So what do I want to do after that? I want to do then on success or catch, getting to the bottom of this, catch on error. It's a similar thing to what I had before, but I just want to make these function names a little bit shorter. If I don't have any error handlers inside my then blocks, right? It will just jump straight to the catch block as soon as any function within my chain fails. So this is the first one, right? Fun1, it rejected. So we don't even get to function 2, I don't think. So if I do console log function 2, I want to see if we even get in there. Function 2. So function 2 does not, we don't even reach it. I don't think so. If you know better and if you think we do, let me know in the comments, but I don't think so. Whereas if this was resolve, function 2 does get called, right? And it gets resolved to this and blah, blah, blah. Now, if I change this back to a reject, and so function 2 doesn't get called, what would happen if I have an on error right after my function 1? So function 1 happens, and then I want to say, then once function 1 is successful, call function 2, but pass in the second parameter, which is on error. Something slightly different happens here, which is if I change this to be success, and I'm going to do string literal success data. So something interesting happened. I have a error handler for the first function by passing it to the then block. So when that happened, we actually continued and hit our unsuccess. Well, because there was a then right after this block. So if I catch it inside the then, if I catch the error inside then, it's not going to stop the code from running the same way the catch block did it. It will actually continue going through the next then. And so that actually changes the flow of data, the flow of information a little bit. So I haven't found a really good case to do this, to catch each of those steps, the errors of each of the functions at each level. You might need to, there might be a case to do that. I can't think of anything. I much rather just do a global error handler inside the catch block, and that's just simply if anybody within the chain errors out. So I'm going to resolve good data, right? And then what happens? Function 1 runs, then function 2 runs. So we have that, function 2 runs, And after that, on success will get called. Let's see, what am I missing here? This should be called resolve, not resolved, success. So I rather do this, and if anybody within this chain rejects it, bad data, it just jumps out and doesn't even go into function 2, and the onError function handles everything. So you have a lot of control here. You can handle each error or handle them globally, or a combination, or nothing at all. You don't even have to catch any of the errors. And finally, the last thing I want to cover here is that there is another method on the promise object, which is called finally. Finally is yet another method that you can call and pass in another function. So let me call another function in the end, in the ned, in the end. Wow, learn to type, buddy. Console log, finally, we be done. We be done, yo. We be done, yup. Right, so if let's resolve everything, resolve, and resolve. And so, and finally, this isn't good naming. I shouldn't be promoting this. Don't call things like in the end. On finally, that might be better. Still not great, but it's better than that. So finally is just an optional thing you can pass into your chain. It's just another piece of code that runs once everything else is resolved. I believe if I reject any of them, finally will still be called. So in case you want to remove any event listeners you might have set up, or you want to clean up after some variables you've created, something like that, we don't really have to do memory management in JavaScript, but in case there was something you wanted to remove, you can do that in the finally block. Now, one more thing, which I promised in the beginning, is let's turn this into a real example where we actually fetch data from a real API. So I've already written this before, so I didn't want to type it here and spend time. So there's a function, fetch data, same thing, return promise object, but it actually uses the fetch API, which is a native thing in every browser now almost, and it calls API that weather.gov. It takes my location, which is 3535. Can you find out where that is? Oh, well, you probably know if you follow me on Instagram. Then it does what the fetch API does, nothing too fancy. And then finally it resolves the data, which is the forecast for right this moment. So what I can do is I can call it fetch data, then when I'm successful, I want to say display data, right? We don't have a display data yet, but I can create it easily. It's a piece of cake. And let's say weather is the thing that comes in. Console.log weather. What is it? Partly cloudy. Right now it's partly cloudy where I am, which totally everybody knows where that is. I don't know if I can turn this into a failure. Let's do a catch block on error or on failure. I can do a function. I'm gonna try to break it, okay? On error, error. Wow, this is awful. Watching me type must be painful, is it? Okay, so on error, that would happen. Let's say I wanted to do, let's break it. I don't know if I can break it. Oh no, I shouldn't be doing that. That's actually like blowing it up. So let's reject. What if I reject? Yeah, partly cloudy. I still passed in the correct data, but you see how now I can handle both the positive and the negative scenarios. So this is an actual workable or working piece of code that it's reading from it's fetching real data from a real API, and it's using promises to handle both the positive and the negative. So to simplify and to wrap up, here we have three functions, fun1, fun2, and fun3. They have to be called one after another, and they're all asynchronous functions. So we have to wait for all of them one by one to finish. Promises makes using these functions a pleasant experience because instead of passing callbacks into each other, you keep the function parameters clean and without any unnecessary stuff like error handlers and things like that. Instead, you define your callbacks using the then block, and you can handle any potential errors using the catch block. And potentially, optionally, if you want to chain a finally block at the end to run any additional code that you want to have to run at the end, you can do that thing too. And that's it. And so those are some of the basics of promises. There's more to promises than what we covered today. So maybe I'll make a follow-up video at some point in the future and go deeper. But it's becoming a long video, so we're going to stop here. I'm going to cover async awaits in the next episode. We'll actually take this example from today and we'll convert it into using async awaits in episode 13. Now, you know what I'm gonna say, right? Please go and practice this stuff. Find a public API. You can probably just Google, public APIs. Find one that is interesting to you. There's a lot of free ones, and play with different configurations of promises, the then and the catch and all those different things I showed you. Start small and understand how to make a promise and then how to return it and how to receive it and how to use it. This stuff is very important for, like I said, for navigating today's JavaScript environment. So I hope you got some value out of this. This was episode 12 of 10 things JavaScript developers should know, but probably don't. All right, I gotta go and get some rest, have fun coding, and see you in episode 13. Async await. I can't wait.